Testing, testing. Okay, we're going to continue with this fantastic series that's actually available online at atlv.org. And yes, I'm just taking the scripts from them. And this one, I'm not going to do any manipulation on. I'm just going to try and explain it more. They provide the GH file and they provide the 3DM file for it. But it's a fairly simple thing. I'm going to shorten this a little bit and show you that it's a surface that you bring in, and it quickly processes that through taking the surface and dividing it into UV counts, panels, creating those panels. And then what it does to those panels is it actually, very interestingly, does a nested loop of panels in a list. And what it's going to do is it's going to run through and think of each and every panel. So if I take each of these panels down to, say, one panel, that's not very exciting. Well, it will do 2 and 2. What happens here is it looks at the panel like it's points. It looks at each one as if it's 1, so 1, 1, 1, 2. I don't know if that's the exact one. 2, 1, 2, 2, 3, 1, 3, 2. And it's going to basically put those in there so you have a slider. They made it parametric so you can move it thinner, which you can see within here, I plus the panel width. And you also have the ability to bring it in and out. And you're like, well, what does that mean by bringing it in and out? Right now they're playing pretty flat. And that's because I have a setting at 0, and they go to full space when I go to 1, because they're kind of reparameterized as 0 to 1. So I could shrink them down to 0, or I can put them at 0.5 or whatever. And you can go in here. A little trick is snapping. You could type in 0.5, and then you'd have a nice snap on that. And make sure you don't put a space after it. So now when you kind of roll it, you'll be like, bing, snap right to 5. And so we've got that going on. Now what I'm doing here is they get their surface. They take the surface that's coming in, all of them, and they, as long as you reparameterize that surface, keep in mind they have to reparameterize that or else you're going to have trouble with the scale of your actual surface. Now what it does is it grabs 2, 1 and 2, 2. And I told you this was 1, 1, 1, 2, 2, 1, 2, 2. 3, 1, 3, 2. So it grabs those middle points and says, let's pull it off the normal. Let's move it this way and that way. And they've got a little bit of math in here that you can take from hard code or these percentages and turn it into a slider if you want to introduce something else on here. But I'm not going to get into that. And I just showed you how you can add there, but you should be familiar with that by now. And so what it's doing is it's moving it along that depth, panel depth. So if I want to pull that middle in and out, I can do that. And it's not going to do too much when it's such a big form. But if I start making these panels a lot smaller by making more multiples, you can see that pulling and pushing of those middle 2 points really has an effect on that panel. Very nice control in a simple script. Now what they're doing is a new tool, which I think is fantastic, is Rhino Geometry line curve. And you just pick your points to make a line between 1, 1 and 1, 2, 2, 1 and 2, 2, and 3, 1 and 3, 2, so that you should be able to walk through these scripts. And what I'm going to do now is just be a little crazy. Go up here and say, listen, we're going to get into this last one, which is a Rhino Geometry making a BREP, and it'll be called a panel surface, and we'll actually take that panel surface and we'll export that by panels extend panel surface. So we need this variable, and this variable is defined by, and panels, of course, now the extend is interesting to me. I guess it's new as a function to go in there and do something with those panels. So I may play around with that a little bit, but what I'm really stuck on, not stuck on, but really excited to find out is that Rhino Geometry, because we imported Rhino Geometry as RG, you have a tool BREP, which is very similar to what we were starting to think about in the past script we just did, trying to find out what we need to do things. I think it was an Intersect Tool there. And you can create from loft. And what it says is, okay, you're going to need a line, maybe 2 lines, but you could have 3 lines. I guess you could have more lines. Put it as many line systems as you want because it's a list. Those square brackets indicate that you've got a lot of information in there. And then this little unset and this unset means you're going to include the first points. And the reason I know this, I'm going to show you exactly why I know this, and the loft type has to be set. And then true or false is going to say, do we want to loop this back around to itself? So what I'm going to do is go in here and just mess with the script a little bit and type in true and show you, once you get an understanding of this breakdown, you're going to loop that right around. So now you get a nice triangle pattern all the way around. And I kind of like that one. It doesn't undulate, but the front certainly dips and weaves and bobs. Of course, I need more screens. That's why I have multiple screens. So you can bob that in and out. It's a pretty fast moving script at 10 milliseconds. Now, how did I learn about all of these things necessary in the BREP tool? Well, I went in and I did what every developer in Rhino needs to start doing, especially in Rhino Commons. Go into uh, uh, your Rhino developer website. Go into your, and I'm not going to leave this because then I got to weed through it and try and find it all. Rhino Common API, and go down to BREP because that's the tool you need. Go down to BREP and scale through it. There's so many ways to make a BREP, and here's creating a BREP from Loft. And as soon as I go in there, it gives me all this wonderful data that solves what's necessary or not. And so they have a C and they have a VB script. Dog's barking, Ella's yelling at me, but I'll get out of here quick. It's her birthday. She's 4 years old today. I'll be home with her for a little bit. And we'll get her grandma on the phone pretty soon. Anyway, so we've got what's going on here is creating a loft from all of these things that have to fit within it. That's C and that's VB, but I'm really in the Python now. When I looked at this, I went down and there's the C examples, and there's the Python example, but it uses Rhino script syntax. It's not using Rhino geometry at RG, so I figure I better go back to C# to find the answers. And sure enough, down there is a pretty familiar looking thing right there. And that's almost exactly what I put in. Now, what exactly is there as you build those variable breps? And keep in mind, this is C, so you have to declare that as a variable. The brep says var. But if we go in, we'll see here's exactly how you build it. You put in your curves, the curves to loft through, yada, 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 yada. Then what was that weird unset? Sorry, not upset. That was the optional starting point of loft if you want to include it as a starting point. So you do not have to type this in, but if you did, then you're going to include that. The same thing with the endpoint. Then the loft is not saying optional, so you have to definitely go in and pick the loft type, and you do that through Rhino Geometry loft type. And all you have to do is hit dot, and then loft type, and then dot, and you'll see what comes up with parentheses, and it'll give you your choices. And then do you want it open or closed, the setting the Boolean, and that's mandatory as well. So you probably could get away with this whole thing if I jump back out of here, just to look at that, because that's where my mind's going as a developer. And if I took out all this unset, I don't know if you have to leave it blank, and that's something I have to still study, like leave commas blank to what's happening and test it. And there it is. It says, no, we don't understand what you're doing there. Let's take out those two, and I haven't tested this yet. Run it, and it's saying segments 3 given. I think I'm definitely going to have to use those for this to work. So I'm just going to go back until I figure that out more. But that's where you're playing now. You're playing with the Python script. And I'm going to go back to false. Actually, I think I'll go back to true because I like that. I'll run it. And we have our little script here. I didn't do much to it, but now it's not a game of what fancy pants moves you can do and what you can make and how you can write this from scratch. What we're really getting into is how do we understand these Python scripts? And yes, you have to go onto some educational site like ALT. And I don't feel like I'm copying or plagiarizing off of this. I'm learning from it. And that's the difference between research and development. Research. As I go through these, all of a sudden there was the nice nerve surface tool. I never thought to go to nerve surface to build my create from corners, 3 or 4 points. I never thought to go to brep and create from loft. Now, I in the back of my mind, I know that's how you do it in Grasshopper. I know that's how you do it in Rhino. So why wouldn't you do it the same in GhPython nodes and how you script? And what's nice is as you get into Rhino geometry, you can see from that exact example that C# is probably where it's at, because if you start getting all these other cases, it seems simpler or more understandable, but you have to learn a whole other language with Rhino script syntax that many of you may have, and there's many tutorials on it, but you can see what they're actually asking. Lofting the surface needs the object IDs, which is GUIDs, not dealing with the geometries that I'm dealing with in Rhino Common, and then which is just a global identifier, which is a big stream 16-bit number or something. I don't know what it is. But it's not something I like looking at. I like looking at the word box, line, point, a lot more than identifiers. Anyway, I hope that makes a little sense. I'm going to record this video, play off of that, and I'll keep going. The next one I'm going to play on, it will be a Panelization Tool, which will keep going with this and extend it a little farther to make it more exciting. I'm going to do their whole examples of how they panelize and make things, and then start selecting, calling out faces, and doing a really nice geometry for an architectural facade. But my goal is not to make architectural facades. My goal is to learn Python, GhPython, and maybe C# and apply this to some very new and different, creative, innovative plugins that do not exist in Grasshopper. Like I said, there'll be another year's time. We'll just keep going. But a nice little parametric fun toy to play with. There you go. Nothing new. Just the only newness is my brain is starting to comprehend it better. And that in and of itself is the gold, that which the gold I seek is not the common gold. Thanks very much for watching.